I welcome all the participants to this small session on random forest and how this can be done using this wonderful product which has been developed as a made in India product known as STATCRAFT. So I'll first go through what STATCRAFT is, what is random forest, what is machine learning, right? And then we'll come to how can we implement this in STATCRAFT. So these are four basic subheads through which I'll try to go through. So the first thing is what actually is STATCRAFT and why have we developed this particular product for all of you, and how can all of you make best use of this particular product which is already being installed in a number of academic and corporates, and people are using it successfully. Now, these are some of the highlights of this particular product, right? The first thing is it's a browser-based application, right? That is the first beauty of this particular application. It's a browser-based application, right? You don't need to install any application either in your laptop or your desktop or your mobile phone, right? You don't need to actually install it. It's a completely browser-based application, and its functioning is very similar to the way you use your Gmail. So you enter a user ID and password, and you are able to access your uh, Gmail account. Similarly, once you are given the link to access the StatCraft, which is either installed in the cloud server or in your local server, it will get open in the Chrome browser. Right, I'll show you the opening screen of the Chrome browser which you get. So this is the first advantage you have, that you don't need any. So this is the screen which you get once you put in your user ID and password. So it's a completely browser-based application. The second advantage is it has two variants. One is with the backend as R, and the second with the backend as Python. Today's demonstration is with the backend as Python. Now R and Python are, as all of you must be knowing, these are the two most popular open source languages which are basically used for statistical analysis of data. So instead of writing the code, which is difficult for a number of people, this front-end application has been developed where the backend is the Python language. So you don't need to do the hardcore coding, and you can use the menus, put in your analysis, and it will give you an output. So you save time going through the pains of writing the code, which most of the people do when they use Python IDE like Jupyter Notebook or Spider, right? So instead of that, I'll demonstrate to you how can you use a graphical user interface of StatCraft. The next advantage is that it can import files of different varieties in which you have the data. You can import a CSV file, you can import a XLS file, depending upon in which format you have the original data existing with you. The next advantage is that you don't need to carry your data set along with you. Once you have uploaded the data set on the StatCraft server, that data set will remain with you, and you can access that data set from any part of the world, the way you access your Gmail account from any part of the world. So the beauty is that you don't need to carry your laptop or the same laptop everywhere which is holding your data. The next advantage is that the data is completely secured because it is stored in the server on your user ID. The way your Gmail, your mails in the Gmail ID is completely secured. Similarly, there is complete security of the data which is accessible only in which it has been uploaded, or the ID through which it was uploaded. So there is absolutely no doubt as far as the security of the data is concerned. Next advantage is the output is permanently stored on the server. So you don't need to make a file of output and save it on your local laptop or desktop. That complete output will be visible to you at any point of time. and you can use that output to write your thesis, to write your research papers, right, at any point of time. You don't need to put in extra efforts to save that particular output. And I'll show you that output also. That is another beauty of it. The next advantage is that the file, if you have uploaded on the server and you have other users on the server from your corporate, from your academia, right, you can share that particular data set amongst all the people whom you want to share. So if somebody, if on a particular project 4 or 5 people are working, so one of the persons in the group can upload the data set and he can share it with the other team members. So 4 or 5 people can simultaneously work on the data set. Somebody doing descriptive statistics, somebody doing inferential, somebody doing machine learning, right? Somebody doing basic statistical analysis. So multiple people can work side by side on the same data set. So that gives you multi-user facility, like you have multitasking and multi-user. Similarly, it gives you the feel of a multi-user facility on the laptop or the desktop. So and it's a totally completely made in India product, right? And it gives you a good, for all those people who are not interested to go into the hassles of learning the code. Then in the output window, it will also generate the Python code. Like I suppose, for example, I show you the output screen. Now this is the output screen of Python or STATCRAFT for Python. And you can see the complete output which is there, right? This output is all the output which you have done or all the working which you have done under your user ID. The advantage is this output will also give you the Python code. This is the Python code, right? And you can copy paste this Python code in the research or in the annexure of your research where you are expected to put the Python code. So that's a very big advantage because now most of the good publications want the code which is generated through either R or Python, right? So naturally they want your research to be done on an open source, and the open source should show what is the code which is generated either through R or Python. So the output window will give you this code. Can you see? And you can just copy paste this code directly to your research paper. This is the command to copy it. It will also give you a formatted output, right? Formatted output in the form of a table, and you can copy paste this table in your research paper. If you are using the naive version of R and Python, like you use RStudio or Jupyter Notebook for Python, then it will not give you a formatted output. So you'll have to first get the output formatted. That itself is time taking, right? Instead, you can use this tabular output directly, formatted output directly from StatCraft and paste it into your research paper. So with all these advantages, right, this particular product has been developed and it is becoming quite a handy tool for all those people who basically want to concentrate on doing their research instead of going into too much hassles of doing the coding, because doing coding itself is a tough task. You need to have a command on the Python right before you can do the coding. So that coding is done automatically at the backend by StatCraft, and it is also displayed in the output window. So it solves that purpose also, where you are required to put the code as an annexure in your publication or in your research paper or in your PhD thesis. So that is also taken care of. Secondly, when you use the coding in Python, there is a concept of libraries, right, and functions. Like some of the popular libraries of Python are NumPy, Pandas, Matplotlib, Seaborn, right? Uh, so there are a lot of libraries in Python. So when you start doing any analysis in Python, you need to have a command on what kind of a library to be used and what kind of a function to be used from that library, right? So that itself is a difficult task, right? So, and you need to install that library and load that library in Jupyter Notebook. Now, this is all avoided when you use the StatCraft. The StatCraft will take care of what is the function and what is the library to do that statistical analysis. And the moment you click, it will automatically, that library will get loaded and you will be able to do the analysis in STATCRAFT. So you don't need to worry, right? That for doing a particular task, like you calculate mean, median, mode, correlation, regression, right? You don't need to worry what is the function and what is the library which has to be used, because anything you do requires some kind of a library, some kind of a function, right? So that hassle is also not there. Otherwise, if you do the naive coding in Jupyter Notebook, the first thing you need to worry about that which function to be used to do the t-test, which function to be used to do the random forest, which function to be used to do the neural network, right? And that function should come from which library. And these libraries are written by a third party. They are all third party vendors, right? Which make libraries compatible for Python. So you also need to worry out of the libraries available, which one to use, right? So that hassle is also not there. We have found out the best library. We have found out whether that function in that library is giving you a consistent performance or not. We have worked on that, and then we have put in that library and that particular function, right, in STATCRAFT. So with all this research being done, this product has been created to make the life easy for research scholars, for people in the academia writing research papers, writing their PhD thesis, and then for the corporates who basically want to concentrate on research, on analysis, on getting findings from the data instead of going too much into the hassles of coding. So this is a brief background of this particular product of STATCRAFT, developed from developed as a made in India product, and then overall it makes our lives easy as far as data analytics is concerned. Any particular question you have as far as the product is concerned, you can put in your queries, and those questions will be handled by people from Predictive Solutions. Now, next is I'll come to the next part. The first part was naturally what is actually STATCRAFT, right? And what is this particular product on? So in nutshell, it's a browser-based application. You don't need to load this particular application. You can share the data sets. Your data set is completely secured. The output is automatically saved. The Python code is generated, which you can copy paste. The output is well formatted. You can directly copy paste into your research paper. Most of the analysis which you do as a part of the research paper has been incorporated in STATCRAFT. It's a made in India application, and naturally it's very easy to use, being a graphical user interface. So these are some broad and basic points as far as STATCRAFT is concerned. If anything I have left out, please feel free to ask as far as the product is concerned. Now let us come to the next part of the story, which is what is actually random forest, right? And where does it come into picture, right? And what does it do for all of us? Now, random forest is basically a machine learning language, right? So I'll just go through a very brief on what machine learning is, where does random forest comes into picture, and then what does random forest do for us, right? And then let us see a small demonstration of running the random forest in STATCRAFT. So there are basically two types of machine learning algorithms, which all of you might be knowing. One is a supervised machine learning, and the other one is the unsupervised machine learning algorithm, right? There are certain things which you can do through a machine learning algorithm like supervised, and there are something which you can do through unsupervised machine learning algorithm. Now, if you see the basic things, right, I'll just enlarge a little bit, though. Now, for a basic machine learning language, you have the input data, right? The data which you have collected And this data set you need to divide into a training and a testing data set. This is the way it is different from a pure statistical algorithm like you talk of linear regression, right? Where it's a pure, or you talk of testing of hypothesis, right? They are all pure statistical algorithms. Yeah. So there you don't need to divide the data set into training and testing. But for all the machine learning algorithms like random forest, decision trees, artificial neural network, right? Support vector machines, naive Bayes, they're all in StatCraft. The one common step is that you divide your data set into training and testing. You can specify how much data should go into training and how much data should go into testing. So that is the ideology as far as machine learning is concerned. Then you develop a machine learning model by using the training data set. So you expose the training data set and let the machine learn. That is why it is machine learning. You make the machine learn, right? And this is the way it is different from programming. In programming, you write the program first and then implement it. Here, you are making the machine learn and the machine is now ready to make that program. So that is a complete reversal, right? Using a data set of input data. So the next step is that I am exposing the training data set and I'm asking the machine to learn, right, as far as the random forest algorithm is concerned. Then once the model has been developed, right, we need to see how good is the model. How good is the model behaving, whether the model can be implemented, whether the research paper can be published on the basis of the results. You use the testing data set. The model is implemented on the testing data set, right? And then you find the accuracy of the prediction, right? Supervised learning means that you are doing some kind of a prediction. You are doing some kind of a prediction. Now, you have a different set of parameters if it is a random forest classifier, and you have a different set of parameters to evaluate the model if it is a random forest regressor, right? So the common step is you have an input data, step number one. You divide the data set into training and testing, step number two. Step number three is you make the model learn on the basis of the training data set. Step number four, you evaluate the model on the testing data set and see how good is the performance of the model. If the model performance is satisfactory, good. If not, then we need to see how can we improve the accuracy of the model. We'll also see what are the different parameters to evaluate the accuracy of the model. Now, if you come to the supervised machine learnings, right? So there are two kinds, supervised machine learning algorithm and unsupervised. Under supervised, we have some kind of a prediction. And the two basic kinds of a prediction is a numerical prediction, which is known as regression. And the second one is a categorical prediction, which is known as classification. Numerical prediction means how many runs India will score, how many marks a student will score, right? Classification means whether a particular customer should be given a loan or not, whether India will win or lose, whether a student will be admitted or not. So that is what is a categorical prediction. So if you are interested for a categorical prediction, you go in for random forest classification. And if you are interested for a numerical prediction, you go in for a random forest regression. The other part of the story is the unsupervised machine learning, which also we'll touch upon in some other session, like clustering and association data mining. Clustering means you are putting maybe you are putting 500 faculty members into 3 or 4 clusters for some kind of a promotion, for some kind of a offer, right? Similarly, you are putting all the different models of car like Ola does into micro, mini, prime, and sedan. That is clustering, right? Similarly, uh, you have association data mining where you find some associative rules, right? Association is like market basket analysis where you see how the product should be stacked, right? Which product should be stacked with some other product. That is where you start finding the association between the products. And the best example is the market basket analysis, which is very popular in departmental stores, where you generally see that wherever you have the bread, you have the eggs and the butter. So eggs and butter are sold, right, in reference to the bread. That is what is association rule mining. Association rule mining. So these are two basic kinds of machine learning algorithms. One is the supervised and one is the unsupervised. Today we are taking up the supervised, and under supervised we are basically taking up the random forest, right? In supervised you have others also. Instead of random forest, you can have decision trees like CART, C5. You can have naive Bayes. You should have support vector. You can have Markov model, right? You can have artificial neural network. All these are examples of supervised machine learning technique, where you can have either a numerical prediction or you can have a categorical prediction. Then in the unsupervised, as I said, you have the whole umbrella of different algorithms for clustering and a whole set of algorithms as far as association rule mining is concerned. So I think all of you have now a very clear picture of what machine learning is, right? What are the different umbrellas of machine learning, right? And out of all this, as of now, we are concentrating on one particular algorithm, which is basically known as random forest. So this completes the second part. The first part was a brief introduction to STATCRAFT, and second was a brief introduction to machine learning, because random forest is an algorithm which is under the umbrella of machine learning. So all of you should know actually where does random forest actually stand, right? And the purpose of using random forest is two. One is random forest regressor, which is for a numerical prediction, and one is random forest classification, which is for a categorical prediction. Now, basically, there are two kinds of variables also we should understand, right? Because once you are starting to do the algorithm, you should know what are the kind of variables you have on the data set. So there are two kinds of variables. One is a numerical variable and one is a categorical variable. If it is a numerical variable, it is either measured on an interval scale or on a ratio scale, like marks, height, weight, right? They're all on a ratio scale. Temperature is on an interval scale. You don't say maybe 44 degrees today in Bangalore is twice hotter to 22 degrees centigrade. That is what you don't say, right? Because the scale is interval. So you should know whether you are exactly using the correct scale as far as your variable is concerned. Otherwise, the machine learning algorithm may not give you the correct result. That is what all of us have to be cautious about, right? Because there is a different set of statistics for each kind of a variable, right? If it is a categorical variable on a nominal scale, then you have something like a mode. If you have a Likert scale, you have a median. Don't calculate the mean of a Likert scale. That is absolutely useless. I have found in so many research papers, people calculating the mean of a Likert scale. You don't calculate the mean of gender, right? So you have to be cautious. What is the variable and what is the scale of measurement? That is why the scale is very important, because it is a roadmap to whether your machine learning algorithm will give you the correct result or not, right? That is the jurisdiction of the researcher, of the research scholar, or the person who is doing the research. I'm just trying to tell all this because it's just not putting in a few lines of code and pick and drop. You should also think whether you are picking and dropping the right thing at the right place or not. So that is what you should be a little cautious about. Now let us go to a brief about what actually is random forest, right? Now there are two words over here. One is random and one is forest, right? Forest is a collection of trees, right? So instead of making a one tree like you do in a decision tree, you just make a one tree, and that based on that tree, you do the prediction. So I'm not doing that. It is not that one student says that the session was good, so it is good, right? I take the feedback from all the people, and then we come to a consensus whether the session was good or not. So that is what the random forest is doing. So in random forest, what we are doing is we are growing multiple trees. We are growing multiple trees, right? And each tree is doing the prediction. And based on the prediction of each tree, we are finally trying to collate what should be the final prediction. Random means if you have taken 10 independent variables, right, under study, then each tree will have a different combination of the variables, which is not there in the decision trees. In the decision tree, you have a single tree, and the second is you have only one set of variables coming into picture. So there are two words involved in random forest. One component is random. Random means each tree will randomly select the variables, right? So if I have taken the number of variables as 5, so from the pool of independent variables, it will randomly select any 5 variables. Second, it is growing multiple trees. And when you are growing multiple trees, that is what is basically known as a forest. That is what is basically known as a forest. So I hope you appreciate the difference between a decision tree and a random forest. A decision tree is a single tree with one set of independent variables. Random forest is multiple trees, each tree making a different prediction, and each tree has a different combination of variables. The only thing is the total number of variables will remain, the total number of independent variables will remain same in each tree. You can't have different number of independent variables in each tree as far as random forest is concerned. Right. So that is what is basically the concept of two things putting together, right? Random and forest. It's an ensemble technique. Ensemble means you are using the answers from multiple trees to derive at the final answer. That is what is an ensemble technique, right? It involves constructing a multitude of decisions trees at the training time. Prediction is based on the mode for classification tree and mean for the regression tree, right? So if you are using a random forest classifier, suppose you are growing 5 trees and the 3 trees make the prediction as yes and 2 trees make the prediction as no, the final prediction will be yes. That is what I mean by when I say mode for the classification. And the if 5 trees are predicting different values of income, then the final prediction will be the mean of all those 5 trees. That is what I mean by mean for random forest regressor. Random forest regressor. So this is what is actually happening as far as the final prediction by random forest classification or random forest regressor is basically concerned. Now suppose I just show you, this is the random sampling, right? The one which you see, the matrix which you see on the left top is the original training data set, right? It is the original input data set. Now from this input data set, D1, D2, D3, these are the different trees which it is creating. So you have to decide that how many trees you want. 500, 1000, 1500, 2000, 2500, right? So that experience you get once you start working on this particular algorithm. Now each tree will have a different set of variables which are written on the top, right? The only thing is the total number of variables will remain the same. So that is what I have tried to show using this algorithm, right? One is, this is the one which is D1, D2, D3 up to Dn. These are the different trees which are grown, right? And each tree will have a different combination of variables. The only thing is the total number of variables will remain the same as far as the tree is concerned. So when you are using a random forest classifier or a random forest regressor, the two basic inputs are how many trees you want to grow first. Second is how many variables you want in each tree. So these are two inputs These are the primarily two inputs for the random forest regression model or a random forest classifier model. So before you start using it, you need to figure out, right, how many trees you want to grow and how many combinations of variables you want for each tree to be evaluated. So this is something, a very basic concept on what actually is random forest. Now let us see how do we do this in StatCraft, right? So that I give you enough time to ask your questions. Now this is what is the screen of StatCraft. This is the login, or this is the link which I am using to open StatCraft in my browser, and I've put in my user ID and password just to save time. Right. Now, once you click on the view, right, this is the four basic views of StatCraft. One is the source view, one is the data view, one is the models view, and one is the output view. So I'll go through all the views one by one. The first one is the source view. Now, this is the source view. This is the view you will use to upload the dataset in Python from your local machine to the Python to the StatCraft server. How do you do that? Can you see this plus sign? Right. So and these are the data sets which I have uploaded on my user ID, the ones which you see on your screen. So I have a number of data sets which I have uploaded on the StatCraft server for the purpose of demonstration. This is the date, the column on the extreme left. This is the date on which I have uploaded it. This is the name of the table. This is a brief description about the table. The columns are the number of variables in that table. Then these are the sample size or the number of rows. This is the size which it is occupying on the server. This is the user ID which has uploaded the data set, right? And the format is basically a structured format in the form of a table. There are two kinds of data sets, a structured data set and an unstructured data set. Table is an example of a structured data set. So this is the complete information of all the different data sets which you have uploaded on the StatCraft server. Now, any data set I want to use, I don't need to upload it again. I just need to open that particular data set and start doing the analysis. So you don't need to carry that data set with you on a pen drive or something else. You just need to open the StatCraft from any part of the world, and the data set is in front of you, which you can use for any kind of a analysis. Now, the first question is naturally to upload the data set. The first hassle which all of you will be having is to upload the data set. So you go click on this plus symbol. Now this is where you need to give the table name. So suppose I give the table name as demo, right? So it will tell you whether this table name already exists or not. So it says exist. So I give you demonstration. Right. So it will also warn you whether you have that table or not. So this is a table name which you can give. Then this is a brief description about the table so that you remember what actual was the purpose of this table. So I say for demonstration, right? Now you click on upload table, right? And then you select which table you want. So suppose I go to my D drive, right? And I take one data set which is by the name of HSB2. Suppose, right? So you can have this data set already existing on your local server or on your local laptop, and then you click on open. Now it will start reading the variables. Now these are the variables which are there, right? If you don't want a particular variable to be imported, right, you can just say cross. So this variable will not be imported. So maybe you have hundreds of variables in your data set and you don't want to import all the variables. So you have the option of removing or discarding any variable which you don't want. There will be certain variables which will be underlined. So you can rename those variables because these are some reserved words in Python, right? So I have these, right? And finally, you click on this OK button. So can all of you see that this is the OK button which I have, right? The moment everything is fine, this OK button will get highlighted. If the OK button is not getting highlighted, that means there is still some issue with the data set which you are importing. The moment you click on this OK, right, this data will get imported, right? And you can see the data set in front of you. If you go to the source view again, then you will find that this particular data set is in the last. Can you see? This data set is in the last. So this way, I have successfully imported the data set in my STATCRAFT server. Now, the next step all of us should do is to see whether the variable view of this data set is correct or not. That is what we call it as the meta view. So you just place your cursor over here and you will find something written M. Can all of you see it? On the bottom, you can see this M written. So this will take you to the meta view of your variable. Now this is the meta view, right? This view is the most important, where you need to set the correct data type and the measurement scale. Now suppose I have a variable like gender, just for example, right? So what should I do? This is numeric and the measurement is, there are two, one is scale and one is category, right? Is it a scaled variable or is it a categorical variable? So if you are doing a random forest classifier, the dependent variable is categorical. So you should take it as a category, right? So your identification of the measurement should be absolutely correct. Otherwise, the machine learning algorithm will go wrong. Similarly, I have a variable like race, right? So this is again a categorical variable, right? So in this particular view, you should set the variable correct, right? One is the data type, is it numeric or is it a string? And the measurement, is it a scale or is it a category? If you have any confusion regarding the measurement, you can always let me know, sir, what should be the measurement of my variable? But in this meta view, you should specifically tell what is the measurement and what is the data type of each variable. So this is what is the meta view. Then the third option which you get is that you can share this data set. Can you see? You can share this data set, and if you don't want this data set, you can delete it using the second button. So the first button is to get the meta view. The second button is to delete the data set if you don't require it anymore. And the third one is, this will give you the share window. So you can share this data set with other colleagues who are working on the same project, but they need to be on the same server. They need to be on the same server. So this is the way you have the source view of your particular variable. This is the source view of STATCRAFT. I hope everybody has understood it. If you still have any problem, right, you can let me know what is the problem. Now I take one particular data set which has 4 variables, right? This data set I have already preloaded. One variable is the risk. The second one is the age, then income and years married. Now I want to make a classification model to predict whether this person is a low risk or a high risk. Low means this person can be given a loan, and high risk means this person should not be given a loan. And this risk is based on 3 independent variables: age, income and years married. What is the age of the customer? What is his income? And what is how long he has been married? Now I want to make a classification model using random forest, right? And see how is the accuracy of the model. How much is the accuracy of the model? So I just repeat, I have 4 variables into picture in my data set. One is risk, one is age, one is income, and one is years married. I want to make a predictive model using random forest, right, to predict the risk of an individual based on 3 independent variables: age, income, and years married. And I have 2 categories for risk. One is a low category and one is for a high category. If the person is predicted as low risk person, he can be given a loan or a loan. And if the person is predicted as high risk, he will not be able to given a loan. So I go to this menu, and in this menu, I go to machine learning, and you'll find a number of machine learning techniques. Like you have multi-layer perceptron classifier, which is neural network. Multi-layer perceptron regressor, which is for the prediction of a numerical variable. You have a decision tree classifier like CART and a decision tree regressor. Then you have support vector machine classifier, naive-bayes classifier, and then finally you have a random forest classifier and a random forest regressor. So we have put in all the popular machine learning algorithms which you can use to make the prediction. The purpose of putting all them are you can use all of them and see which algorithm is giving you the best prediction. That is the reason that a research scholar will go through all these algorithms, right? And then see which is the algorithm which is giving you the best classification model, right? As far as the prediction is concerned. So all this today we are concentrating on random forest, but I wanted to tell that you have other bunch of algorithms also into machine learning as far as STATCRAFT for Python is concerned. All the ones which are the most popular ones which people use. Neural network, decision trees, support vector machines, naive-bayes, and the random forest. Now you click on random forest classifier and you can give any title as loan. Suppose I give the loan prediction. So I'm making a model to predict the loan. Now this is the dependent variable, right? So I just click on plus sign in front of risk. This is my dependent variable. Do remember the dependent variable has to be categorical in nature, right? If your dependent variable does not have the measurement as category, then everything will go wrong, right? So the dependent variable has to be a categorical variable like risk, and then we have the independent variables as your age, your income, and your years married. So you can have any number of independent variables coming into picture. The beauty of machine learning is that these independent variables may not have a nicely distributed normal distribution data, which is absolutely useful or required if you are going in for a pure statistical algorithm. So that is one advantage of using a machine learning algorithm. Then you can go to save, and then you can have a predicted values, what is the model predicting and what is the probability. So these predictions will be shown as the output, right? Then you can save this model, give some model name, right? So suppose I say again loan prediction. Now, what is the advantage of saving the model is once you have made the model, right, you need not make the model again. You can use this model to make the prediction for future customers. That is why you want to save the model, right? You don't want to go into the hassle of creating this model again, right? So I have saved it with some name, and later on you can use this model directly to make the prediction. Then you go to options. Now these are the different criteria which you have, which you require to make the model. One is the criteria for selecting the most important variable, and that is what is known as the Gini index, right? So basically there are two ways. One is Gini index and one is entropy, right? So you try to minimize the impurity, and the one which has the highest purity is the most important variable. So that is the computation which the Python is doing for us. But we need to tell what should be the criteria for selecting the variable. And that is what is Gini index. Maybe some other time we can have a full session on understanding how is Gini index calculated. How is Gini index calculated, right? So we'll see sometimes how do we actually calculate the Gini index. But as of now, since we are more interested to build the model, we can take the criteria as Gini index. Then bootstrapping is true because we are trying to make the training and testing from the data set. So that is why bootstrapping is true. Then we have some of the parameters, right, which should go into making the model. Now these parameters, the best ones we have actually put in, but then these parameters can actually change as far as your requirement is concerned. I'll start with the most important ones. What is the training size and what is the testing size, right? So training size, if you can see, I have put in as 75%. So if you have 1000 cases, then 750 cases will be used to make the model, and your model will be evaluated on the remaining 250 cases. So this is in your hands. You can make it 75-25, 80-20, 70-30, whatever you want, you can put it over here, right? So that is the train size which you can specify, the one which is the most important. Then you have the seed value. This seed value helps you to store the training and testing, because the training and testing is randomly selected, right? So if you give a seed value, then the next time when you run the model, you will get the same training and testing. Otherwise, if you don't put a seed value, every time you run the model, maybe on the same laptop, you will get some different results, because the selection of training and testing is random. So that is what many people say, sir, yesterday I run the model, yesterday I created the model, it was giving me an accuracy of 90%. Today I'm creating the model on the same data set, I'm getting an accuracy of 80%. This can happen because the selection of the cases in training and testing is randomly, right? So just to freeze what should be the training and testing data set, you can put in this seed value. This value is any number, right? It is a nominal. That means it is just for allocating a memory which stores the training and testing, and this is what Python remembers, right? So this again is very important, is the seed size actually, right? Now let me do this, a small example for all of you. By using this particular things, I say, okay, now this random forest classification will run, and see, this is the output which I get. So let me explain first the output of this random forest classification. So this is the random forest classification. This is the output which it begins from, right? Now these are the most important thing, these libraries which are used to run this model, right? This is the hard part of the story. So if you are doing your coding by yourself in a Jupyter notebook or Python or Spider, then you need to get hold of these libraries. Like pandas is used for importing the data set, numpy is for numerical. Then for making the random forest model, we have used the function random forest classifier. Can you see random forest classifier? And this library, this function is present in scikit-learn or sklearn.ensemble, right? So this is what STATCRAFT is automatically doing for you. It's a very difficult task, right? So this task is actually taken care of. It is loading all the libraries which are required to run the random forest classification and to evaluate the model. So I'll just read out pandas, numpy, random forest classifier is the actual library or for the algorithm. Then train underscore test underscore split is the library to divide the input data set into training and testing depending on the test size which you have given. So this is the beauty of this fourth number library. Then to generate the confusion matrix, which I'll show you, which will show you the accuracy of the model, is you are using the function confusion matrix, right? So this is where the importance of this library comes into picture. And finally, we have the library of classification report, which will give you the other parameters to evaluate the model, like precision, sensitivity, specificity, right? Recall, F1 score. So all these can be calculated directly if you use the classification report library from sklearn.metrics. So each of these libraries are very important, which are indirectly loaded by STATCRAFT, and you are not worried about it. I remember all these libraries because I use it every day while writing the code in Python. That is why I'm able to tell you what is the importance of each library. Next is, this is the code to import the data frame, to import the data set as a data frame in STATCRAFT, right? So that is the next code, right? And then this name of the data frame, as you see, is df. From this df, we are creating x and y. What is x and y? X is the set of your independent variables, age, income, and years married. And y is the data frame for your dependent variable, which is your risk. This is what is Python doing it, or StatCraft doing for you. I hope the sequence is clear now to all of you. First, it has imported the relevant libraries. Then it has imported the data frame, imported the file as a data frame. From that data frame df, it has created two data frames x and y. X is holding the independent variables and y is holding the dependent variable as specified by you in the menu. Then you are using the training and testing data set to split it into xtrain, xtest, ytrain, and ytest. So you use a single function and you create 4 data frames out of it. Xtrain is to make the model. Xtest is to evaluate the model on the training data set. Ytrain is the data set of independent variables for the testing data set, and ytest is again the dependent variable data frame. So using a single function, you are creating 4 data frames. Xtrain, the set of independent variables for training data set. Xtest, right? Xtest is what? The set of independent variables for testing data set. Ytrain, the dependent variable for training data set, and ytest is the data frame for dependent variable for testing data set. Now the final thing which we do is to make the model using random forest classifier, right? So this is the code for running or creating the model in Python. And then once the model is created, I fit this model on the training data set. Once the model is fitted using the .fit function, right, we see what is the accuracy of the model using the confusion matrix. Now let us see what has happened on this data set from the above code. The first thing it will give you is what is the importance of each variable. How each variable is important as far as the risk is concerned. And as you can see, the maximum value is age. So whether a person should be given a loan or not, the most important variable is the age of the person. Out of the 3 variables which we took, age, your income, and years married. This is one beautiful answer which you get from Python. How important is the independent variable in predicting the dependent variable? So my first question to the customer will naturally be, what is your age? Because that is the most important variable that will decide whether the customer should be given the loan or not. Then is the income, and then is your years married. So it gives you a very good understanding on how important is your independent variable. Then naturally it has done some kind of a prediction, and we need to see how good is the prediction. For that you have the confusion matrix. Now confusion matrix is something like this. You have rows as high and low, and you have columns as high and low. So this is actual versus predicted. Now this is telling you what, as far as the training data set, can you see this 8? 8 means what? The actual data set has 8 cases in the training data set which were high, and the model is also predicting it as high. This is true positive, right? True positive, right? Then then you have low. High versus low is 0. That means of the cases of high in the training data set, the number of predictions for low are 0. Similarly, you see low versus low is 5. That means what? That 5 cases were actually low in the training data set, and they were also predicted as low. So if you see, there is no element which is off diagonal. This is also 0 and this is also 0. So accuracy of the training data set is what? 8 plus 5, 13 divided by 13, which is 100%. So your model is 100% on the training data set, but more important is the testing data set. In the testing data set, you have how many cases? 3 plus 1 plus 4, 5, right? So 8 plus 5 is 13, which was the total sample size. Now, high versus high is 1 and low versus low is 1, but there is one case which is actually low, but the model is predicting it to be high, right? So this is not correct. So your accuracy is what? 2 divided by 1 plus 1 is 2. So 2 divided by 3, which is 67%. So actually, the accuracy of the model is only 67%. So you need to work a little more harder because you should have a minimum accuracy of 90% in order your model is good enough for publication. So this is the way you read the confusion matrix, right? So actually, it is true positive. True positive means actually it is yes, and the model is also yes. True negative means actually it is no, and the model is actually also no, right? False positive means actually it is false, but the model is giving it, actually it is no, but the model is saying it to be yes. You don't have corona, but your lab report says you have it. That is false positive, which is the most alarming situation. And then you have false negative. That means actual it is yes, but your model is predicting it to be no. So 4 terms are there: false positive, false negative, true positive, and true negative. This is the way you can find the from the confusion matrix, the accuracy of the model. Now, besides the accuracy, there are certain other things which you need to report, like the precision value. Precision is your sensitivity. If you are more concerned about the true positives, then you should calculate the precision. Precision is what? True positive divided by true positive plus false positive. Then recall value is the sensitivity, right? So true positive divided by true positive plus false negative. Then the F1 score. F1 score is the geometric mean of precision and recall, right? So the best parameter to report is the F1 score, because here you are taking care both of the uh, how true, what is the condition of both precision and recall, right? Both the aspects you are taking care of. One aspect is the precision and one aspect is the recall. So that you are giving equal importance to both the parameters. So that is where you can report the F1 score. Then accuracy, already I have told you, true positive plus true negative, which we already did in the confusion matrix, divided by true positive plus false negative plus true negative plus false negative. And the last one is the specificity. If you are more worried about the true negative, how good is your model behaving as far as true negative is concerned? If that is your primary concern, then you can calculate the specificity, which is true negative divided by true negative plus false positive. This is the formulas which I have shown you, and the same formulas are used to get this value for precision, recall, F1 score, right? Which we have calculated using the classification matrix of Python, using the classification matrix for Python. So this is the way you can do the random forest classifier, where you are making a categorical prediction with a set of independent variables, and you can report how important is the variable, how good is your model looking at the confusion matrix for accuracy, and then you can report the other parameters, which are basically your precision, recall, F1 score, and your specificity. So this is the way you do the random forest, right? You don't worry too much about the libraries and the coding, and you get the results which you are more worried about: how good is your model and how good are the independent variables as far as predicting the dependent variable is concerned. So random forest classifier is used for a categorical prediction. Now, similar to this, we have a random forest regressor, where we are more interested to go into a prediction of a numerical variable, right? So suppose if I take the same data set and I want to predict, suppose I say the same data set. So I go to view and select data. So it will go to the data view, right? Now this is showing me the predicted values also. Can you see this is for the first case, the actual value is low and the model as predicted is also low. And the probability is 0.96. The probability of this is 0.96, right? So this is from where you get the confusion matrix, because confusion matrix is the cross tabulation between the actual risk and the predicted risk and the predicted risk. So you can also see in this output also what is the probability, what is the prob. Now, if I want to predict a numerical variable, what is the what should be the income of the person based on his age and years married? If that is the model I want to make, if I am continuing with the same data set, if I am continuing with the same data set. So income is a numerical variable. Income is a numerical variable which I want to predict. So the next feature which STATCRAFT gives me is you go to machine learning and there you select random forest regression. Random forest regression. So we have given you both the options. Either you are interested in to make a predictive model with categorical prediction, or you are interested to make a predictive model with numerical prediction. So I say prediction is for income. My dependent variable is income and my independent variable is age and years marriage. Right. So do remember the dependent variable should be numerical in nature. We have also put a constraint. If you don't select a numerical variable under dependent, STATCRAFT will not accept it. So that is the filter we have kept, so that you don't need to worry about whether you are using the right variable or not. If by chance you are using a wrong variable with a wrong measurement level or a wrong data type, then the STATCRAFT will not accept it. STATCRAFT will not accept it. And it will give you a warning that you need to relook at the measurement level and the data type of the dependent variable. Now again, you can save the model. I can give the model name as income, right? And the predicted values, right? Then you go to options. Now here the criteria will be MSE is the mean squared error, right? And MAE is the mean absolute error. So we can check the criteria as mean squared error. So the criteria also changes. Here you are minimizing the squared of the errors. There you are using Gini index or entropy. I'm not going too much into Gini index or entropy, right? Gini index is the amount of impurity, right? So how do we calculate Gini index, which is though internally done by Python, but then we can also look at how Gini index is calculated, not a big deal. So the criteria changes. Here we will see how to minimize the squared of the errors. And the parameters again remain the same. You have the train size, you have the seed value, right? Which you need to specify as far as the model is concerned. You click on OK. Now this is what is the mean random forest regressor, right? So you again have the libraries, pandas, and the sklearn library. Now can you see the function imported is random forest regressor, right? So you have the random forest regressor. You have the train test split for breaking the data set into training and testing. And then you have the metrics library, which is used to find out how good is the model. How good is the model. We import the data set as DF, create two data frames X and Y. X is for holding the independent variables and Y is for holding the dependent variable. We create four data frames X train, X test, Y train, Y test from the train test split function, right? And then we make the model, we fit the model, and then we get the metrics which shows how good is the model. You can just click on this and you can use this copy button and copy this into the Word file or annexure where you are writing the code. You can select this table and copy it as a formatted output in your research paper. Now this shows that the number of years married is more important than the age. So this will again tell you how important is that variable in predicting the dependent variable which we have taken as income, and according to my data set, years married is more important compared to the age of the customer. Then we have the metrics which shows how good is the model. So the most important one is the mean squared error. This is the mean squared error, and then you have the mean. These are the different metrics which you have as far as the error is concerned. This is for the training data set, right? And this is for the testing data set. Now, out of these, the one which we can use is the mean absolute error, right? One is the mean absolute error and one is the mean squared error, right? So the smaller is the mean squared error, the good is the model. Good is the model. So if you can see the testing data set, the mean squared error is this much. And for the training data set, the mean squared error is this much, right? This is the mean squared error. So what I'm trying to say is the smaller is the mean squared error. Jitna chota hoga, the smaller is the mean squared error, the more efficient is your model predicting the dependent variable. So you can put in all these parameters. All the parameters are actually telling the same thing, but the, whichever parameter the reviewer wants to use, he can use it. He can use the mean absolute error. He can use the mean squared error. Python is calculating all these, like you have accuracy, sensitivity, specificity, F1 score, recall for a categorical variable. Similarly, you have these different metrics for a numerical variable, right? So this will also help you to understand how good is your model predicting the dependent variable. So this is actually you are coding free and you are getting the output which is more important for you, whether your output meets the criteria of a good publication or not. If not, you may change to a different algorithm, because in STATCRAFT we are giving you the other algorithms also for doing the prediction. Now, if you go a little more deep into it, this was just an overview of how random forest is implemented with a very brief on machine learning and random forest. But if we go into more of random forest, you will understand, right, how many independent variables to take, right, what should be the combination, how many trees to grow, right, all that calculation can be understood, right, before you go on to make the actual model. But here it was a small demonstration trying to show you that this is the way on any data set you can implement these two beautiful machine learning algorithms, the random forest classifier for a categorical variable and random forest regressor for a numerical variable.